All right, so now we're going to talk about increasing, decreasing, and constant intervals, and then where you might find sections that are called relative maximum or minimum on functions. So there's a bulleted list here of what makes a function increasing, decreasing, and so forth. I don't think that those definitions are very intuitive, so I'm going to tell you a different way. So for the first one, it says a function is increasing on an open interval if the f of x1, right, shown here, is less than f of x2. Really what that means is that the y value, right, at this point is less than the value at that point. And that says whenever x1 is less than x2. Okay, so really what this means is as you move from left to right, just like you would read in a book, if you look at 2 points on the graph, if the first point has a smaller y value than the next point and so forth, then the function is increasing on that interval. If the function, if you're looking at 2 points from left to right, has y values that are getting smaller, right? This is the first y value, this is the second y value. And here, y1 is greater than y2, or if you'd rather, y2 is less than y1, it's decreasing, right? So if you're reading from left to right, the value of y is getting smaller, you're decreasing, okay? And then, of course, if the y value stays the same, right, as you see in these two, well, that means that the function is constant there. Where do you find relative max and relative min? Again, by the definition, it says that f of a must be greater than f of x for all x not equal to a. Well, but what it really means is to its immediate left and right. So if we look here, this point right here, all the values to its left are increasing. All the values to its right are also getting bigger. So that point's the lowest point on the graph relative to its position, meaning it's a minimum there. And then at this point, right, this point is higher than all the points to its left. It's higher than all the points to its right. Therefore, it is a maximum. Another thing you might note about minimum and maximum is when we're talking about increasing and decreasing, right? If we look at this function, this one is decreasing up to the maximum or minimum in this case, and then it begins to increase from then on. So those points sometimes happen at a change from increasing to decreasing, okay? All right, so let's take a look at this first example here. Keep in mind that if we are doing equal to, we're using brackets. We're using parentheses for not equal to, or infinity, or if we have a change at that point. Okay. So first off, I think it's easiest to say where is the max or min. So for this one, and remember this is a parabola. If you remember on a parabola, we would say that the point where its lowest point or it's where it changes shape, let's say, is the vertex. And the vertex, right, in this case, is the lowest point. It could also be the highest point. So you might remember when you did parabolas for the first time, you would find max and min of the function, and that was to find the vertex. And so in this case, it's a minimum, and that minimum is at the point x equals -1, y equals -4, and the y value is -4. Okay. So for the relative min and max, we're going to want to report the point and the y value. And for the intervals, we're going to want to put the x values, but as an interval. Another thing that might be good is at the beginning of each problem is to write the domain and range. Okay, so the domain of this function, right, the values of x that it can have, well, this continues on in both directions, to the left and to the right of 4 forever. So the domain is all real numbers, or minus infinity to infinity. And the range, the values that y can be, well, it goes on forever in the upwards direction, so it goes on to infinity, but it can only go as low as -4, and we're going to say equal to there. Okay. So that'll help you when you're doing your intervals of increasing and decreasing, right? Especially if you talk about the domain specifically. So for increasing, from this point on, the function, the y value is getting bigger and bigger as we go from one point to the next, going from left to right. Therefore, it's increasing from, we're talking about the domain, so x right here, -1 to infinity. And it's decreasing on this side, so that's from negative infinity up to -1. And so you see, right, if we combine these two, we go from negative infinity to infinity, which is our entire domain. So that's good. And of course, if there's a constant area, that would be included as well within the full domain. But in this case, we do not have a constant region. And because we had a minimum and the thing continues on forever upwards, there's no relative max. All right, let's continue on. So we have this function here. Now this function begins at -1. There is nothing beyond that in the x direction. And it continues on for infinity. So we could say our domain, right, of the function, the values that x can be, are bracket, we can equal -1, and we go on forever to infinity. And if you just wanted to do it, we could say the range, right, which is the y values. Well, the y values start at 0 and they go on forever as well. So it'd be 0 to infinity. Okay. So clearly you shouldn't have any maximum or minimum or anything outside of those values. So that's a good way to start. All right. Now, if we look at points on this graph, it appears to me that no matter where I look, this function is always increasing. So from one point to the next, from left to right, the y value is getting bigger and bigger and bigger. Therefore, there is no section of decreasing, or none, and increasing is from, or is the entire domain. It's -1 to infinity. Again, if it's increasing all the time, there is no constant area. And the question is now, do we have a maximum or a minimum? Well, if it's increasing forever, right, there is no maximum. There is a minimum, right? There's a point that we can get to that's smaller than all of the other points. And that is right here. Now, I did say the points to its left and right. Well, this point doesn't have anything to its left and right, but it is relative to the points near it. So this point is going to be x equals -1, y equals 0. And if we want to do it as the value of y, we would say y equals 0. Now, later on, we'll refine that type of minima, but for now, we'll just call it relative. Okay, so for this next one here, first let's do domain and range. So the domain looks like it continues on forever on the left, it continues on forever on the right. And so it looks like we're going to pick up everything, all real numbers for x. So -infinity to infinity. And the range, right, the values of y I'm allowed to have, well, it doesn't get any higher than 2, and it doesn't get any lower than -2. And because I equal those, I'm going to use brackets. Okay. Now we want to talk about where is this thing increasing, decreasing, and constant. Well, let's go from left to right, just like we'd read the graph. So starting out at negative infinity up to x equals -4, this thing is constant. So minus infinity to -4, okay? Then between -4 and 0, it's decreasing. And just because it looks like it takes a little bit of a change in the curve there, right? The line changes slightly in direction. It's still decreasing. So it's decreasing all from -4 all the way to x equals 2. So decreasing from -4 to +2. And then we are constant again from, let's see, we're constant again from 2 to infinity. And so I need a union here. All right. So again, you should see that we pick up all of our domain, right? Minus infinity to -4, -4 to 2, 2 to infinity. And that's everything, right? That goes from minus infinity to infinity. Now, if we've taken the entire domain, that means there's no area where this is increasing, and that should be evident by the graph. Then the question is, do we have relative max or relative mins? Well, that would mean that from left to right, as we read along the graph, there has to be a point that to its immediate left and right, all of the values are either less or greater. And I don't see a point, right, anywhere I pick here. Maybe here, for instance, right, the point to its left is higher, the point to its right is lower. So there's, right, it would have to be something like this for that to be a minima. And for instance, we pick one of these points, right? The points to its right are constant. So they're all the same. And then these are getting bigger if we went to the left. So there is no max, there is no min. All right, let's continue on with this last example here. All right. So this is something like a sine or cosine curve, right? Not important, but just again, like to give you guys some things a little extra here and there. I'm hoping that you see there's no points as we read from left to right of this guy that are constant. Again, let's go ahead and do our domain and range. So the domain is, now notice we do have a point here and a point here, which means this thing stops and doesn't go on forever. So x starts at -5 and goes up to 5, okay? And we're equal because it stops. If it was an open circle, it would be parentheses. All right, what about the range? Well, it looks like we're going between, as a maximum, or as high as we can go is 4, and as low as we can go is -4. Okay. So I just said, right, maximum or minimum. So I'm hoping you're noticing that this is a relative min, this is a relative min, this is a relative max, this is a relative max, and so is this. All right. So relative maximums are y equals 4, and they occur at the points -4, 4. Let's see, 0, 4. and 4, 4. Okay. And then minimum, they are y equals -4, and they happen at -2, -4, and 2, -4. All right. Now we're expecting between all of those points for there to be something going on, either being constant, decreasing, or increasing. We've already said no places where this thing's constant, right? So what about increasing and decreasing? Well, it is increasing on this region, on this region, and on this region. So we need to describe those. That would be from -5 up to -4. Right, so we equal -5 because it terminates there. We do not equal 4 because it changes at that point. Okay. Then we are also increasing from -2 to 0. And we're increasing from 2 to 4. Okay. And we are decreasing everywhere else. So that's going to be this region, and this region. So that should be from -4 to -2, 0 to 2, and from 4 to 5, and we equal 5. So we terminate there. So again, you should see, right, we're increasing from -5 to -4. It's right here. Then it's decreasing after we hit the maximum from -4 down to -2, right? And you can keep following the graph that way. Okay. All right. I also wanted to point out that in some instances, this point here and this point here are considered relative minimums, but they are not going to be what we're going to refer to later on as points of inflection. Okay. And also, just be careful, right? I've been using these brackets because we are equal to at those endpoints, but I'll take a look at the homework problems and just try to see. They may want you to just use parentheses still, just as a formality, but technically you would be equal to at those points. Okay.